This is Ryan Womack, Data Librarian at Rutgers University Libraries in New Brunswick. And this is the recorded session for R for data analysis, a Tidyverse approach. And I'm going to pick up where the previous introductory video left off and start out by just reviewing the websites that we need. The previous video, the intro video, will be the place to go if you need discussion of R, discussion of how to install R, those kind of things. I'm assuming right now that you're starting this session with a functional RStudio and you're ready to go with R for data analytics. So I'm going to use, and again, I'm just going to put the notes up in the top right so that you can see these web links a bit more easily. They'll also be in the code down in the description down below. And I'm going to go directly to the GitHub site. And once again, this is where the code for this session is going to, this session and future sessions resides. You can click on the green button to either download the zip and just download it to your local computer, unzip it, and you'll be ready to work with the files there. Or if you're a Git user, you can do something like the following. So I'm going to change to my R directory, and I'm simply going to copy this link, and I'm going to say git clone and the link. This is the easiest way to grab all the files using Git. As I mentioned earlier, we're going to schedule a Git, very basic Git session later in the semester as well. So now you can see if I go into the directory for Tidyverse approach, I have all of those files from this site that have quickly been grabbed and put in this environment. So you can have R installed on your own system, RStudio installed on your own system. I will mention one other way to get to R, which is rstudio.cloud. rstudio.cloud is well named because it is a cloud version of RStudio that is provided by the RStudio people. I've already signed into mine. You can create an account that gives you 15 hours of free usage per month. It has become a subscription service where if you need to use more than that, you do have to pay for that. But as a place to play around and experiment, it's an easy way to get started. And here, if I wasn't logged in, you'd get a login screen that has a link to create an account. It's pretty straightforward. You can connect it to your Google account or GitHub account, or create a custom account just for RStudio Cloud and log in there. If you need to do that, pause the video and come back. And if you're using this method, then all you need to do to grab the materials is to say new project from Git repository and put the full URL to the Git repository in here, and it's going to do something like the following. It's going to deploy the project, and then you'll see in a moment an RStudio environment will pop up that contains all of those files in its directory. So this is a quick way, And again, one thing that's great about RStudio is that the interface is the same no matter what platform you use it on. So this is going to look the same as when we're on our system. But I'm not going to use RStudio Cloud for my own demo. I'd rather just use my own system. So I'm going to actually go back to my workspace, and I'm going to delete this project so that I don't use hours from my account. And I'll just close that. Okay, so before we launch RStudio for real, I'm going to go to this file that says R for data analysis.md, which we saw in the intro if you looked at that. And down at the bottom, there's this question: what is the Tidyverse? Right? Why are we calling this the Tidyverse approach? Okay, so R has been around for a while, and R has all these features that do data analytics. What happened? Why do we need the Tidyverse? Well, Tidyverse describes itself as an opinionated collection of R packages designed for data science, which share an underlying design philosophy, grammar, and data structures. So one thing about R, because there are many packages coming in from many different places, is it tends to be less consistent than you might expect. And now that there are 15,000 plus packages, it is harder to get started or know where to start in R than it used to be. So Tidyverse has come along. These are packages designed and basically led by RStudio people who are the main developers for the most part. Although it is like any other open source project, there people can contribute from various places. This gives you a set of packages that'll do a lot of your basic data analysis and are designed to work together nicely without, sort of special munging that you sometimes have to do with other things. Also, there is great documentation, which we'll see, and because it has become quite popular, you'll see a large community using these approaches. So for that reason, I'm going to introduce R with the Tidyverse approach, not saying that other approaches, including base R, are not worthwhile. Those are also worthwhile. But to start with, I think this is a good way to look at things. And the website, tidyverse.org, actually has documentation on all of the major packages in a very consistent way, which I'll refer to that as well as we go through. Okay, so now I'm going to launch my RStudio, and this is I'm running this on a Linux system. There's a little bit of a quirk on my system, which I have to adjust a command to disable the GPU acceleration before I run RStudio. Otherwise, I'm prone to have crashes. So if you're wondering why am I doing that from the command line, that's what I'm doing. Okay, so I have now my RStudio interface, which I have customized, and you can customize everything here by going under the Tools, Global Options, and changing the appearance. You can change how the code is highlighted, the types of fonts that you're looking to use, and the look and feel of the whole thing. I tend to prefer this kind of dark background, but you have all those options. You can also, in RStudio, you'll notice that there are these quadrants or panes, they're called, in the view. These can be customized and moved around, and you can customize what displays in those quadrants. So it's all up to you how you'd like to handle that. I've stuck with the default quadrant arrangement here, though. And unless I have a code file that I'm working with, I actually start in this, what's called the console in R, which is just a bare bones terminal that we can interface with the computing system. Now you'll notice here it starts with, I'm running R version 3.5.2. That's because I'm running a kind of a older stable version of Debian Linux. And although the new version, R has moved on to version 4, on this particular computer, I'm just being a laggard for now. So you'll see that. These starter messages can also be customized, which I might mention a little bit later. But let's stick with the basics here. I'm at the console. It's got a blank blinking cursor. What do I do at this point? Well, I can actually use R as a calculator. I can type things like 2 plus 2, 2 times 4. Whoops, sorry, that's a plus. Square root of some number. I can get some large numbers, 2 to the 300th power. And you can see this is the sort of interactive nature. What I type something and I get a response. Now, the strength of R, however, is when you build up a code file and you actually have a very systematic, structured way of working through your data analysis. Although R captures the history of your commands when you're typing in this form, a code file is going to be a better approach. So I mentioned the history, and you can actually see the history by going up to the top right and clicking on the History tab up here. You notice this is actually just the commands that I've typed. It doesn't record the output, however. We're actually going to talk about how to grab the output a bit later in the series, because the way to do that most effectively is not in this basic mode. Okay, so we want to actually work with a code file. How do I do that? Well, my bottom right window down here is set to the Files tab. I've set my default directory to be an R directory in my home folder. It's probably a good idea for you to leave your data projects, separated in some way like that, and not mingle them in with other files on your system. And so I've got some things that have been installed in my R directory, one of which is the Tidyverse approach directory. So this is the place, no matter how you've downloaded these files, you've just manually downloaded them on your system to some place, your desktop, your whatever, or you've cloned them, or you're working with them on the RStudio cloud. Just go to that directory and you should see the files here. Now we are going to use this file, R for data analysis.r, for this particular session. And any file ending in a .r like that, a capital R, is considered to be an R code file. There's nothing special about these files. They are just text files. You can create them with any text editor and they will run. And a lot of systems, like if you're used to just clicking on a file and having your computer know what to do with it, that's probably not going to work the first time you do it with something like this. You're going to have to get into a program that understands R, like RStudio, or change your computer settings to link the R files with the program or RStudio or something like that. So yeah, sometimes I've had that question where people just can't get the file open because they're not used to they're used to the computer making the linkage for them. That sometimes doesn't happen, and the way around that is to go into your R environment. Here we're using RStudio, and then open it from there. Okay, so you'll notice what happened is now my additional pane or quadrant of the screen has opened up as a code analysis up here. And my console has been squished down into the bottom left. So we're going to live like that for a while. I'm going to make the right-hand side a bit smaller so we have more room to see these things. And this is a great thing about the RStudio interface, is you can customize all that. If I'm just working on typing code, I can click this little window, sort of large window icon, and I can toggle that window and make it larger. I can toggle it again and shrink it back, or I can minimize it, and now I can see all the console. So I want to really see my results. I can just, toggle back and forth really quickly, those things. But for right, I'm going to try to stick with the split view for as long as makes sense for this session. Another thing, just we're going from the basics, is that if we want to write a comment in our code file, we start with a hashtag symbol, or what used to a long time ago on a phone be called a pound symbol. And that means if we type that like down in the console, if I type hashtag 2+2, well, nothing happens. You'll notice that it just returns me to a blank cursor, because that's now a comment that doesn't run as a computer command. Nothing that starts with the hashtag will run as a computer command. So, however, it does accept the input and just kind of return us back to the empty blank line. This is the nature of R, is that it's not going to tell you much about what it's doing unless there's output or unless there's an error. Now, if there's an error, you'll get a warning of the problem. And we'll see an error pretty soon. So I've tried to comment my code in a basic way. When you write your code, this is a good practice to explain what you're doing. And what I've done here is very basic commenting. But that means that line 9 is the first line of actual commands to run. And I'm going to start out by just typing the commands. And then I'll explain how you can speed that up a bit. So on line 9, the command is getWD. So I'm going to just type getWD with parentheses. If I type it with a capital G, you'll see this is what an error looks like in R. It couldn't find that function. And so we know there's a problem. That's not going to run. You'll notice also as I typed, this is a feature of RStudio, not base R, that it gives us a prompt. It starts to tell us, hey, we see you're typing GETW. Do you mean get WD like this? And then it even has help to explain what that function is. And we can press F1 to get additional help if we want to. So RStudio has this sort of feature that'll help you learn and remember the commands as you go through. But now we know that actually we should be typing a lowercase getWD. And what that shows us is actually the working directory. So getWD is just shorthand for get working directory. And it'll show us that we're now sitting in my R directory. So one point here is how the errors work, how the built-in help prompts work, and also that R is case sensitive. It is variable names, command names, all case sensitive. If you're not used to being careful about the case, you'll learn once you start using R. Another thing is if we look at line 11, getWD, if we type it without parentheses, what happens is we get information returned to us that's a description of the function. Now this is a little bit sort of internal, kind of computer readable, not human readable code. But we'll see another example of this in just a moment. Also, what the parentheses basically mean is to execute the command with the default options. And we'll understand a little bit more what that means in a minute. Okay, so now we're up to line 13. We've already seen this in action. We can use the console as a calculator. And we can create our own function. So we've seen just one function in action, getWD. If I want to create my own function, now I'm on line 18 of the code, I can give the command a name, the function a name. I'm just calling it funky add. This is nothing special. I can name it, and you can change the name to be whatever you like. And what I'm saying is funky add is going to be a function of two things, of x and y. Now, if I'm going to move to copying and pasting this information, just to avoid any typos. And I'm going to hit enter. And you'll notice something else happen down here at the bottom left, that what used to be a greater than sign has converted to a plus. That plus is a sign that we didn't type a complete command into R. R is waiting for some additional input so that this command will make sense, so that it'll be complete, and we haven't provided it yet. So we have said we're creating a function of x and y, but we haven't said what the function is. The function itself has to be enclosed in what we call curly brackets. Those are living just up above your return key on your keyboard. And RStudio will actually complete the second bracket for you, because these always have to be parallel, right? If we open a bracket, we have to close it. Otherwise, there's going to be a syntax error. So here, and I'm just, to make it very clear, I'm adding an additional enter. And actually, in the original code, I have this spaced out so that what's inside the brackets is separate. It's a little bit harder to type it like that. So I need to slow this down a bit, and I'm going to remove the second bracket just so that I can space it out the way I originally wanted to. Okay, now I type the function definition, and I'm just going to say x plus y plus 1, and I'm going to close the brackets. Notice these are all pluses on the left. But once I close the bracket, my cursor goes back to a greater than sign. And if I'm stuck over here in the history tab up at the top right, but if I look at the environment, you'll now notice that I have something called funky add in my list of things in the R workspace. Another way to list things in the R workspace is just a basic ls command with parentheses. And you can see I have funky add and I have q. Q is actually something I just have built into my system. You probably won't see that. You don't have to worry about the q. The funky add, right? So now it's a function. It's here. If I type funky add without parentheses, I get the definition of the function. And this is exactly what we have just put in. And so it's a function of x and y. It's defined by x plus y plus 1. And if I want to use the function, I can put parentheses. Now, if I type it like that, I'll get an error because I haven't actually provided what is x, what is y. There are also ways to define the default values of those numbers so that you wouldn't get an error in this case, but we're not going to worry about that right now. We're just going to put in some numbers. So if I say 2, 3, instead of 2 plus 3 being 5, it adds another 1 and it becomes 6. So this is a place where we can make 2 plus 2 equal to 5 if we want to do so. All right, so that's this very simple function. Maybe you think that's not a very useful function, but the point of making a function in R is that it's very easy for the user to create something that's on the same level as any other built-in R function with a command like this. And in between the brackets, you can put whatever you want. You can have very complex conditional tests for things that are going to set up the result this way if certain conditions are met. You can have all kinds of procedures all within the brackets. And this is actually the genesis of how our packages are created. They're like the interstellar dust from which the stars of packages ultimately form. People write functions. They need some stuff to get done for their work. They've got a few functions. They find that, hey, this is useful. It could be useful to others. And they move forward with creating that in a usable form for other people. And R makes it easy to do that. We'll talk about that in upcoming sessions, moving to that level. Okay, so I want to mention just a couple of other things before we get into the real data example. But I want to make it clear that R has lots of everything that you've ever heard of in statistics. R has it somewhere, either in the built-in or in a package, because R is the primary research tool for statisticians to, develop these things, test them out. If it's been done empirically, you're going to find it in R. And so simple things like a sample. I want to create a sample or draw a sample of numbers between 1 and 100. And let's say I want to see 10 numbers drawn from the range from 1 to 100. Now you'll notice I typed that with a space instead of in the original code. It doesn't have a space. R is not terribly sensitive to spacing. Like I can really space it out like that, and it still reads okay and still executes the command. It is sensitive to case, as we saw. It is sensitive to punctuation. It is sensitive to closing out any brackets or parentheses. But spaces, not so much. Okay, so what happened? I got 10 numbers from the range from 1 to 100. And, there are lots of variations on this. If I say I'd like to sample just the numbers 1 through 5, but I'd like 10 of those, it's going to give me an error in this case. It'll hint at why. I cannot take a sample larger than the population. What it likes to do is draw each number once, and that once the number is picked, it's no longer there. So if I sample 1 through 5 times, I'm always going to get each of the 5 numbers, but in a different sequence. And once I try to sample a 6th time, it's going to basically break because there's no numbers left to pull out. But you can see that it's told us that the problem is this option that says replace equals false. So I can change that option. So I can sample 10 times from numbers 1 through 5 with the option replace equals true. Just like that. And now it will, it pulls 1 out, but it puts the 1 back in. So it is possible to draw a number multiple times. And in this case, we drew 1 4 times and 5 3 times. And every time you run this, it's a random process, so you'll get a different set of numbers. So we want to find out, okay, we've seen a little bit. Okay, how do we know to use that option? We can access the help system in R quite easily by simply typing a question mark in front of any command. So if I say, what can I do with the sample? I can say question mark sample. And here's another case where RStudio is really nice, because RStudio, if you try this in other R interfaces or just the base R, well, I'll show you what happens. In just a terminal version, I say question mark sample. It's going to give me the same help, but it's all on one screen, and it's kind of in this not so nice plain text format that I have to scroll through. It's there, but it's not so ideal. whereas in RStudio, the help appears nicely formatted, nicely out of the way in our bottom right window. Okay, so here's the sample. This is a function that does random samples and permutations, and it shows us the usage. So we sample X. X is, in this last case, is our 1 through 5. The size of the sample, our last example, we asked for 10. And we can say replace equals false or true. And we can say prob equals null. We can actually specify probability weights, right? So, for example, the default is an equal probability. But we could specify there's a 10% chance of getting a 1, there's a 20% chance of getting a 2, and so on for a custom probability draw. Also, we don't have to only sample numbers like we did in this simple example. You can sample from a list. You have a list of names, you have a list of addresses, places. You could sample from those and just get a random grouping from your data. So this is typical of an R function, that it has a very basic, straightforward initial use, and then you dig in the help. You try to figure out how the function works, what other things can be modified, and you can do more advanced things. And all of the help format in R looks a bit dry. It takes a little bit of getting used to, but they're all written in the same format. So once you get used to it, you're able to digest help from any package, essentially. So here we have this, description of how each argument of the function works. Sometimes there's a discussion of, details. So this does talk a little bit more about exactly how the replacement works and things like that. And down at the bottom, the very last part, you're typically always going to get some examples of using the code. So sometimes I'll just jump to that, say, I just want to see how a usable chunk of code to see how this works. That's in the help also. Okay, so we've seen an R function, but more importantly, we've seen the help that's accessible via the question mark. I'll also mention, just as another example of a statistical function, like a reverse norm. R norm is a random sample from a normal distribution, and the standard normal distribution has a mean of 0 and a standard deviation of 1. So when we just run R norm in a very plain form, we're going to see numbers centering on 0 and between mostly -2 and 2 typically. But we can modify that via the options. For example, in line 28, we can say mean equals 100 and SD equals 20. And in order to run this command, I'm going to start using my RStudio features a little bit more as I go through. I can highlight this and use the run button. So I say run up here, and it'll paste that whole line down below. And so now I've got some numbers that are centered on 100, and plus or minus 2 standard deviations away is where most of those results are going to lie. Now, if I do a question mark here, question mark R norm, you'll see the help I get is actually for the whole family of stuff we can do with the normal distribution. So it's a density of the normal distribution, the probability, cumulative probability function, the quantiles of a normal distribution, and a random sampling from a normal distribution. This is available not just for normal distributions, but everything. Poisson, Bernoulli, logarithmic, like everything that you've heard of. Again, you will see in R a function corresponding to it. And once again, the format of those that help is standardized, and if you want to see examples of some of these, you can go down to the end to see those examples. Okay, question mark is probably going to be the lion's share of the way you use the help will be via the question mark name of function. But you can also access the entire help system by going to this help tab on the right, clicking on the home, and you'll see there's resources for learning R. There are full manuals that are there for like an introduction, how to import and export data. And then particularly useful are the package references. Under reference, you'll see packages. And this is a list for each package. We can quickly get to the functions associated with that package. And also we can do a search across everything. So if we want to search for things that might involve a normal distribution, we might just search normal. Now, if you go on Google and you just try to search R, right, R is just a letter, so it's a bit of a pain sometimes to search for R help. I might search R stats and then like the name of some concept on Google. You can also, if you have a specific error message that you get, Google is great if you paste in that error message and then say R or R stats. That'll work. But often you really want to search within R itself. And so the search that's in the help is searching among all the functions that are installed in packages on your R system. Here are things that, in this case, mention normal distribution, so that's going to be a lot. But we can find out, all these things, right? So there's the normal distribution in the base stats package. There are also other normal models that are built into these other packages. And the first thing before the 2 colons is the name of the package. So there is stats package normal. There's also MGCV, MVN, so multivariate normal additive models built into this MGCV package, for example. So I encourage you to use the built-in help. It's in HTML format, but it's actually locally installed on your system. So even if you don't have an internet connection, you can access this help. And, it's, again, a little bit dry, but it works and you get used to it. And it's good to learn how to make effective use of the help. Okay, so now at this point, we're some ways in, and this may be a good point to break the video in parts so that the next part will start with using the data. So I'm going to break here, and I'm going to say thank you for listening, and